Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface and talk about a very important topic when we are using JNI and C++ to access some of the arrays, especially the array types of the Java in C++. So in the past lectures, we saw how to actually access the elements of an array, get them or set them in the C++. However, the problem with that was, so if I go back to our lectures on the array types, working with primitive, especially primitive array types, we said that we asked JVM to either create a new double array for us in C++ and we can send it to Java, or we can say get double array region and set double array region, right? So we create a C++ or C style array, and then we use the, for example, get double array region. And this is the Java array, J array pointer, J array, and then we set the start index, length of the array, or basically the, and then the C style array. And what the JVM does is when we use the get double array region, it copies all the elements of this primitive array type, which it already knows on the Java heap, copies them into the C style array. Basically what we are asking JVM using this primitive get array region or set array region is that we are manually copying from Java heap to C native heap and vice versa, right? So we already know that an explicit copying is happening. We are asking JVM to do the copying, so there is a copying involved, and if the size of array is very large, then this copying can have a significant overhead, so we have to be aware of that. So how do we avoid it? So actually what happens here is that JVM provides us some specialized methods or functions. Basically the JNI provides us that it can actually return a direct pointer, C style pointer, right, to whatever the primitive array is on the native heap. And obviously this has some consequences and JVM has to be cautious about it. That's mainly because of the garbage collector that is running on the background. Okay, so the JVM has to somehow figure out how to deal with the garbage collector when it's handing over the control, the direct control of that primitive array, which is an object, right, a Java object, and gives us a direct pointer, a raw pointer in C++ to that array object on the Java heap, right? This is, JVM has to be very cautious about it. So when we say get double array region and we pass a Java array and then basically the index from start to end, and then what happens here is that we already know that JVM is basically copying, right? We ask JVM to manually copy them. We create an array in C, and then JVM copies the elements of this primitive array, which it already has under the Java heap, and copies them into our C array, right? And then however, JVM also, so this was for the region, which is index based. So this is like a start and then end basically, and then the C array, right? And then this gives us, what it gives us is a basically it doesn't actually return anything. So it does not return anything. It just directly copies the Java array into C array, get double array region, when we use the get double array region. However, JNI has another function, get double array elements, all right? And we just pass the Java array, J array reference. It could be a J double array, J int array, or a general array, right? And this works for primitive type. And then it has another pointer is copy, which is a J boolean pointer. But then this returns us basically this returns a raw pointer, a raw C style pointer. It's a primitive pointer. So we can use array elements, get double array elements for the double arrays, Java arrays. If it's int, we can use get int array elements. So the first one is region.
The second one is elements, ends with elements. So what happens in region, we ask JVM to copy them, explicitly copy this Java array into our C array. And obviously we can perform our calculations with the C array, and then we use the set double array region and copy the C array back to a Java array, right? However, when we use get double array elements, this returns a raw pointer, a primitive pointer. So we pass in the reference to the J array, and then it has also a boolean, so it can return a boolean, which is copy. And if we use get double array elements, it returns a raw pointer, J double pointer. Now at first look, you might say, okay, this is great. So JVM now is giving me some control. It gives me some raw pointers, which JVM typically considers very dangerous for the user to work with these raw pointers. However, the problem here is that this actually JVM doesn't actually give up control, and it doesn't. This primitive pointer, it's not a direct pointer to the actual J array. That's why we have this isCopy parameter, right? So if we define a J boolean and pass the pointer to that J boolean here, JVM also returns this flag. And when we use this, there is a high chance, like 99% chance, that this flag returns back as true, which means this pointer is actually not the direct pointer to the Java heap, the array that the JVM has. What JVM does actually to not give up control on the array is that it actually behind the scenes creates another copy of the Java array, and the way it does it just uses the clone. Remember that the clone method for the primitive array types in Java are built into the JVM. That's one of the rare cases that an object, the clone function in the object is already implemented by JVM, right? So array types, for example, a primitive array type in Java, the clone method has been actually implemented inside the JVM for those primitive arrays, right? So the JVM actually knows how to clone primitive arrays. It clones it, returns this isCopy flag as true to us, and then gives us a raw pointer to that copy or clone of the original array. And again, this is because JVM doesn't really want to give up control over the array. So however, again, because behind the scenes, even with this get double array elements, a copying is happening, this could also have significant overhead, because in the first approach, get double array region, we create a C style array, we ask the JVM to copy them over. So this is an explicit copying. We know that copying is happening. With the get double array elements, we actually are not sure if copying happens, but we can check with this isCopy flag, and 99% of the time JVM will make a copy behind the scene and gives us a raw pointer to the copy. Okay. However, what do we, so this has overhead. Obviously, if the array is very large, let's say it has more than 10 million elements, this has a significant copying overhead, because we're just spending a lot of time copying. And if we don't want that, especially for large arrays, what we want to JVM to give up control on the array, on the Java heap, and give us direct access to that array. And the way we do that is that JNI was implemented in such a way that it actually has this method or functions that end with critical. Critical means JVM says, okay, this is a critical operation, so be very careful about what you're doing. I'm giving up control over this Java array, and give you a direct pointer to that array on the Java heap. So this is a critical operation. JVM allows us to directly manipulate Java heap for primitive arrays using critical access. So instead of saying get double array elements, we say get primitive array critical. So we don't really specify the type. Whatever type it is, we just say JVM give up control, give it up, and then give us a pointer, a direct pointer to that object on the Java heap. I want to be in full control. So JVM doesn't like to give up control, but in this case we ask it to actually give up control. So get primitive array critical, we pass in our Java reference to the Java array. It could be a J double array, J int array, whatever it is. And we also still have this flag. And most of the time, I guess 99% of the time, this flag comes as false, comes back to us as false, which means this is not a copy. JVM didn't make a copy behind the scenes. This is a direct access. That's why it's marked as critical. But because we don't have a specialized method for different types, it's just a get primitive array critical. This is one function. So the type of raw pointer that the JVM returns back to us is a void pointer, which means the type is not really specialized. And what we can do, we can just do a CS style casting on this and cast it to a J double pointer or J int pointer or to whatever we want. So this function, critical access, returns back a void pointer. The type is not specified. We have to manually typecast it. However, although JVM gives up control when we use these critical functions, we need to make some promises to JVM, right? So basically, when JVM gives up control on this J array, a primitive array, and remember, primitive arrays are objects, Java objects, so they are subject to garbage collection. So JVM temporarily disables garbage collection on this array that gives us a pointer to. All right. So JVM tells garbage collector, okay, ignore this object for now. I'm giving up control on this object, so you don't touch it for now. And then what happens here is that and therefore we have to promise JVM that we're not going to use any arbitrary JNI functions that might alter somehow the state of some object that has this array as its field or something like that. So we have to be very careful. Basically, we shouldn't use any, after we use this critical function, we shouldn't use any other JNI function until we're done with this critical access. And how do we tell JVM that we're done with this critical access? We use a release primitive array critical. So release primitive array critical, and then we send the J array and also the pointer that we got, and then JVM knows, oh, okay, now he's done with this critical access. I enable garbage collection on that, and after that we can continue using other JNI functions. All right, so be very careful about this critical access, and when you get the critical access, you shouldn't use any arbitrary JNI functions until you're done with this array type. And I mentioned this in the previous lectures, but it's good to mention this one more time. In general, when we use JNI functions, any JNI function that returns a raw pointer to us, for example, a J double pointer, const char pointer, which is the case for strings, it also has a release function associated with it. For example, when we say get a string UTF chars, and it returns a raw pointer to us, const char pointer, and then we have to say release a string UTF chars. All right. So same thing here. When we say get double array elements, and it returns a raw pointer, then we have to say release double array elements and pass the double array object and then the raw pointer that the JVM gave us. Same thing with this critical access for primitive arrays. When this get primitive array critical comes back to us, it gives us a pointer. It's a raw pointer, although its type is undefined because it's a general type. It's a void pointer. We still have to tell JVM that release primitive array critical, and we pass in the J array and then the pointer to it. All right. So this is very important. And once we go into this critical access, at least we are sure we have high confidence that no copying happens behind the scenes, but we still can check with this flag is copy if an actual copy happened. With critical access, there's a high chance that copying doesn't happen. So let's head to Eclipse and try to explore this. I'm going to create a new package. Let's call this test 27. And then in test 27, let's create a new class called test array critical access. Let's have a main method. What I'm going to do here, I'm going to create a method called test1, and then test1 is public static void test1. And let's create a couple of native methods. So public static void. So what I want to have a native method that takes a Java array, a double array, a primitive array, and adds a double value to it. So add, and then I'm calling it add copy. So and then double vec or double array, and then double x. So this is going to add x to all the elements of array. And the reason I called it add copy, because I want to use the previous methods that we use, get double array region. This an explicit copy happens, and then get I want to use the region elements and then critical. So go back here. So maybe it's add region. And obviously I have to mark this with native so that it doesn't require an body, and then add elements. So for this one, add elements, I'm going to use get double array elements, work with the raw pointer that the JVM gives me. And finally, I'm going to say add with the critical approach. All right. So for the first one, I'm going to use get double array region. For the second one, I'm going to use the get double array elements. And then for the last one, I'm going to use get double array, get primitive array critical. Get primitive array critical. And we look at the differences when we implement these in C++. All right, so JVM. All right, so what I'm going to do here, let's create a double array. The A is 1.1, 2.2, 3.3, and double X, or we can just say that so we invoke the add region, we send X and let's say -5, and do a sysout on the arrays dot to a string on A. Obviously if I run this, I get the unsatisfied link error because we haven't implemented this yet. So let's also load the dynamic library that we're going to have, system.load library native _C. All right. So what I'm going to do, I'm going to go to C++ perspective and then select my test array critical access and run the Java H tool. And this Java H tool basically runs on the bin directory and then creates the header file, puts it in the native C. It's my C project in the header folder. So let's run this Java H tool. All right. So the header file is now should be generated, test27. So we have add region, add elements, and add critical. All right. So then we go to the source folder and then create a source CPP file. Let's say array _ critical.cpp. All right. And as always, the very first thing that we do is we include that header file, test27. All right. And then we copy and paste these function prototypes. All right. And we start adding body or implementation. So JNI environment pointer, we call this JVM. And then J class is the calling class, because this the Java method is a static method. So we end up with a J class reference to this class, not J object. So my convention is the class name _ class. So J class and then J class. And then J double array, let's call this A. And J double, let's call it X. All right. So what are we going to do? In the first one, it's the region, right? So what I need to do, I need to get the length of this array. So JVM get array length. And we pass in the A, this array. And then what I need to do, If I want to use a get double array region, I have to create a C style array. So J double C array, and then with some length, which is the length, and then say JVM get double array region. All right, and then J double array is A, start 0, the length or the size is len, and the buffer is C array. So I'm manually or explicitly asking JVM to copy this Java array to this C array. All right, and then what I need to do for int I equals 0, I less than len and I plus plus, I just say C array I plus equals x. Remember that the JNI primitive types map to the C++ primitive types. And now that I do my operations on this C array, which originally have a copy of the original Java array, I have to copy them back, right, in this J double array. So because I'm returning void, which means I want the operation to happen on this original array. So JVM set double array region, and then A start 0 len, and the buffer is C array. Okay, so we are doing two copying happens. This is the first copy because JVM copies them into the C array, and then we copy the result back. So this is the second copy. Two copy happens, and you can imagine if the size of array is very large, then this two copying might have a significant overhead. So let's build this. Maybe let's also print some messages. So include IO stream, and then I'm going to say std cout inside add region method or function std endlen. So let's build this. Build is done. Let's copy and paste the dynamic library to Java and override the previous one, and then let's run this, and hopefully this works fine. Yes, inside add region method, and we successfully added the maybe let's also print the array before sending it to C++. So we are adding -5 to the elements of this array. So 1.1 plus -5 is -3.9, 2.2, 3.3. But we did, in order to do this, we had to do 2 times copying, one from Java heap to the C heap, right? C++ heap, or basically this is a stack. So it's not, we're not allocating this C array on the heap, but still it's a copying, and then another copy back. All right. So let's go to test 2. In test 2, we're going to do the same thing, but here I'm going to use add elements. So this add elements, what happens in C++ is that now we ask JVM, instead of copy them in the C array, we ask JVM to give us a pointer. So inside the add elements method. So what I'm going to do, so we still get this length because we need it for this for loop. And then let's see what happens instead of saying J double, instead of creating a let's see array is JVM get double array elements, and then Java array and is copy. So let's create a JBoolean is copy, and then is copy, and let's initialize it with false. All right, and then we have this requires a JBoolean pointer, so we pass the reference, and then this comes back. So what I'm going to do is basically print this JBoolean, the state of this is copy after it comes back from this function. So I'm going to pass in bool alpha, and then pass in is copy and std endl. Okay, And then when we use get double array elements, we have to basically, what we need to do is we have to also release it. So release double array elements and then the second one is C array, and the mode doesn't really matter, so we can set 0 here. So what happens here, instead of us explicitly creating an array and copying it, right, copy the elements over, what happens in this case is that the JVM creates a copy on the Java heap and gives us a pointer to it. We do operation on that, and then we still need to use this set double array region. Okay, because I think we don't have a set double array element, set double array. Yeah, so we have to still use this set double array region, which means another copy happens. So the first copy, which still we are not sure if the copying happens or not, if this is a direct reference to the array or this is a copy, and it's determined by looking at this is copy when it comes back. But let's see what happens. But again, what happens here is that we are doing our operation on this pointer. If this was a direct pointer, what happens here is that the original array should be basically affected. So maybe let's not do this set double array region and see what happens. So I'm going to build this and then copy and paste the dynamic library and overwrite the previous one. Let's go back and try to run test2. So in test2, remember what we're doing here is that we are getting a pointer to some array, a J double array pointer. So obviously our hope is that this is a direct pointer to the array on the Java heap, so we can manually this operation we hope that this operation will directly change that Java array on the Java heap. But if this C array is pointing to a copy of that original array, then this should not change the original array, right? So let's see. So I send A, I create A, send it to C++, and then print it again. And this comes back positive, right? So let's see, JBoolean, and then add elements. So basically what happens here is that release double array elements. So what happens here is that JVM copies back to the, because now what I'm doing here is that I'm telling JVM that when you release it, you tell it, okay, release the C array into the original Java array, and JVM does a copy back. So we don't really need to do this set double array region. JVM does a copy back, but this is still a copying, right? So we are still doing two copying. And then let's see here, std bool alpha is copy, and okay, so what I'm going to do in order to see it, because right now we didn't see this character, so what I'm going to do, I'm going to convert it directly to bool, right? Because I'm passing bool. JBoolean is unsigned char, and when it's 0, which means it's false or true, or 0 or 1, we don't really see the character. So let's build this again, and then copy and paste back to Java, overwrite the previous one, and then let's run test2. Now it says it's true, so it's actually making a copy. All right, so what happens here is that in this case JVM is helping us and it's making a copy, and then it's not making a copy, it's giving us a direct pointer, which is good, right? Actually JVM is making a copy, so is copy comes back true, which means JVM is telling us, yes, I actually did a copy. I thought it didn't make, but this is copy. If it's true, it means it actually made a copy of the original Java array. So let's write it here. JVM is actually making a copy. All right. So what I want you to understand the difference between the first approach using get double array region and set double array region, and then get double array elements and release double array elements. What happens in the approach here is that here we create the C array ourselves and we manually ask JVM to copy them. So it's a manual copying. We choose to copy them and JVM does it for us. But in this case, we ask JVM to give us a copy. So copying happens by the JVM behind the scenes, and this is copy flag comes back positive, which means true, right? And then when we release the result, the C array, this pointer into the original array, JVM copies them back. So this is the second copy. All right, which is still not good because two copying happens. So if the array had a large number of elements, let's say 10 million, 100 million elements, then 2 times copying is a significant overhead. So let's move on to test 3, and this is where the critical access happens. Add critical. So let's invoke test 3. And for the critical, I'm going to copy and paste basically the same code here. The only difference here is that I'm going to, let's also delete this. What I'm going to ask JVM to do is get primitive array. Get primitive array critical, array is copy, send a reference, and then this is copy comes back. I convert it to bool and set the bool alpha to the standard output so that I can see whether it's true or false. All right. So I get so this returns a void pointer, so I have to manually typecast it. So j double pointer, and then when this comes back, I have to ask JVM to release primitive array critical. C array is the C array, and the mod doesn't matter. Okay. So it's more or less the same code. Instead of saying get double array elements, we say get primitive array critical. So it's interesting to see what happens in this case when this is copy flag comes back. So if it's true, it means JVM actually made a copy behind the scenes and gave us a pointer to that copy, not the original array. If it's false, it means that JVM did not make a copy and it's giving us a direct raw pointer to that array, the original array. All right. So let's build this. And then let's copy and paste the dynamic library back. And let's run test 3 with this array critical. And now is copy came back false. We still get the same results, but now basically the is copy flag is false. Remember in the second case with the pointer, with the raw pointer that we got, the is copy came back true. But now it's coming back false, which means this is not a copy. That was a direct pointer. Get primitive array critical gave us a direct pointer, and then we typecasted it. We did our operation on the pointer. All right. So what if we don't call this release primitive array critical? What happens here? Because now we're directly manipulating the array. So the problem is that if we don't do this, JVM doesn't tell the garbage collector to actually start. So when we call get primitive array critical, JVM tells garbage collector to ignore this object for now. But then it's up to us to tell JVM when we are actually done with this object, and now the garbage collector can be able to index it and reclaim it. All right. But in terms of directly manipulating, in order to see if this release primitive array critical is actually doing a copy or not, I can comment it, and I can also do the same thing with the second one, because we said that when this release double array elements happens, JVM actually copies the C array back, this pointer back to the original array. But let's comment it and let's build this project again. And let's see what happens now. It would be very interesting to see the result. So let's start with test 2. And in test 2, I'm getting a pointer, and I'm pretty sure it's a copy. It's a pointer to a copy of the original array. So, and because I'm not releasing, what I think is going to happen is that the original array is not going to change. So let's run test 2, and the original array doesn't change. So the change happens when we use this release double array elements, and then JVM takes this pointer, which is pointing to the copy, all right, the copy, and then copies them back into this array that we specify. All right. And then what about the test 3? In test 3, we know that it's a direct copy. It's not a copy, it's a direct access. So once we manipulate this pointer, it's going to actually change the elements of the array on the Java heap, right? So let's see what happens here. Yes, the original array does in fact change if we don't call this release primitive array critical. So this is indeed a direct access to the elements of the Java array. All right, but then we have to use this to JVM so that JVM knows that we are actually done with this critical access. It's not going to block the garbage collector again, right? It's not going to continue blocking the garbage collector on this array. So this is very important, so don't forget to use this release method. And as I mentioned, in general, the general rule is that whenever you use a JNI function that returns some raw pointer, you have to at the end you have to use the release function that comes with that original function. So if it's a get something and it gives you a raw pointer, you have to use release something. All right, any get method that gives you a raw pointer has a basically dual function that starts with release, and you have to do that. All right, in the case of get double array elements, copying back to the original array happens here in the release. In this case, when we call the release, no copy happens. What happens is just tells the garbage collector, hey, it's done with this pointer, and then now you can go back and index, get a hold of this Java array again, which is an object. All right, so I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.